Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 34, and this problem asks us to label each of the following compounds aromatic, anti-aromatic, or not aromatic. So, if something's going to be aromatic, it must be fully conjugated. That means every single carbon in the cyclical structure must be sp2, it must be cyclical, and it must follow Huckel's 4n plus 2 pi electron rules, with n being any integer or 0, so that can mean we can have 2, 6, 10, 14, etc. pi electrons. So this is to be aromatic. To be anti-aromatic, you must be fully conjugated. That means everything must be sp2 hybridized. You must be cyclical, and you follow the anti-aromatic 4n rule, where n can be any integer. So it could be 4, 8, 12, etc. And to be not aromatic means that you're not completely conjugated, meaning that you have an sp3 carbon in your cyclical structure. So if you look at A, we actually have 2 sp3 carbons here. They have 4 things bound to them, meaning that they're going to be sp3. So right away, we know that this molecule is not fully conjugated, so it's impossible for it to be aromatic. And because it's not fully conjugated, it cannot be anti-aromatic either. So now let's look at B. So B, we have sp2, sp2. Every single carbon here is an sp2 carbon in the cyclical structure. And now let's count the number of pi electrons. We have 2, 4, 6, 8, 10. So we have 10 pi electrons. And if you look at the 4n plus 2 rule, 10 actually falls in between this. So yes, this is actually aromatic. Now, what about C? Well, C, we have sp2, 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 sp2 carbons, and then this carbocation is also sp2 because it only has 3 things attached to it, but this opposite carbon is sp3 carbon. So this is not aromatic either. Now, what about this structure here? So we have full conjugation system, and these lone pair electron actually exists in a p orbital, so it actually can delocalize and be involved in aromaticity and calculation of aromaticity. So let's see if this follows the 4n plus 2 rule. So we have 4 pi electrons, but we actually see that 4 pi electrons follows the anti-aromatic rule of 4n. So D is actually anti-aromatic.